All right, this is 13.2, the ideal gas law. So the ideal gas law is a combination of Boyle's law, Charles' law, and Avogadro's law. So keep in mind that with Boyle's law, Charles' law, and Avogadro's law that you can only change two variables. We talk about pressure, we talk about volume, temperature, and the number of moles. You can only change two variables with those two. But what happens if we need to change more than two variables? And what I'm talking about is if I come down here and it won't let me get a pen, maybe. There we go. Maybe it will. All right, maybe get like a pen, maybe. Here we go. Here we go. Yep. So what happens like if I talk about when I'm talking about two variables, like pressure, volume, temperature, the number of moles. So I have those four variables. That's what we talk about with gas laws. So with like Boyle's law, I can only change pressure and volume. So P and V. Charles' law, I can only change V and T. Avogadro's law, I can only change V and N. So that's only two of those letters. What happens if I need to change all four of those letters? Well, that's where the ideal gas law comes into play. PV equals nRT. That allows for me to change four of those variables versus two. Or even if I need to change three, if one's constant, it's not a big deal. You still have a number for it. So notice I have all four variables, P, V, N, and in fact, now I have a fifth thing, I have R and T. And we'll talk about what this R thing is here in a minute, the universal gas constant. But pressure is P and it's in ATMs. So the big thing with this too is that everything has to be in specific units. So pressure has to be in ATMs, V, volume has to be in liters, and mole is moles. T, temperature in Kelvin. But now we have this R thing too. R is the universal gas constant. And we'll talk about R here in a different slide. But so the big thing is that you'll be taking your pressure times your volume, and you'll be setting that equal to the number of moles times the universal gas constant times your temperature. So you have this basic equation, and we'll run through some examples here in a minute. But we have this nice gas law that allows for us to now change multiple units. So we have this R in there. The R is the universal gas constant, and it's a constant, meaning that you're always going to use this 0.08206 every time. And so it's a constant, and that's why it's so important that we use those specific units when using PV equals nRT, because if not, you can't use that universal gas constant. Keep in mind that this is an ideal gas equation, meaning that it's set up for the perfect environment. For the most part, gases act as a perfect ideal gas. Ideal gases, remember, that are gases that have a pressure of about 1 atm or lower, temperatures of 0 degrees Celsius or higher. And not all gases act this way, but for the most part they do. So we can use this equation, and it works pretty well. So what we're going to do now is I'm going to walk you through two examples of how to use the ideal gas law. And so here's the first one, and then you're going to walk through this second equation that's in your notes. All right, we're going to start by writing down our equation. And so I have PV equals nRT. All right, and then usually what I do is I write all my letters over to the side, just so P and V and N and R and T, just so I can write down everything that I have before I plug it into my equation, especially if I need to change any of my units. It allows for me to visually see everything that I have, so if I need to make conversions. So the problem gave me 728 millimeters of mercury. So I wrote that down, and then volume, I don't know. Then it gave me 0.210 moles. So I'm going to write that down. Okay, then we have our constant, our R, which is 0.08206, which never changes, right? That always stays the same, and then 27 degrees Celsius. So that's everything the problem gave me. So I wrote all that down. Then I need to start looking to see what I need to change. So notice I have millimeters of mercury. I can't have millimeters of mercury, so I'm going to do a conversion there. So I'm going to change millimeters of mercury to ATM. So I'm going to do a conversion. And so I'm going to put 760 millimeters of mercury on bottom, 1 ATM on top. That's why we did all those conversions. Plug that into my calculator. And with sig figs, the given is 3. I can have 1.03 ATM. And so now my pressure is in ATM, which is the appropriate unit for pressure. Next, notice that my temperature is in degrees Celsius. I can't have degrees Celsius. So to get from Celsius to Kelvin, you just add 273. So now that's 300 Kelvin. And so now my temperature is in the correct units. So looking through all of my variables, P, V, N, R, and T, everything is in now the correct units. So I'm ready to plug into my actual equation. So P, 1.03 times V equals N, which is 0.210, and then take it times my R, which is 0.08206, and then take it times my temperature, which is 300. So look at the setup there, and then I'll be ready to do the math. So I'm just going to multiply all those numbers over to the right. A lot of times what I like to do, if I have a calculator that allows for me to set up variables, I set my calculator up so I can actually plug in R into my calculator and keep it there. But either way, you're just going to multiply all those numbers together. So now I have 1.03 V on the left-hand side and 5.16978 on the right-hand side. I'll have to divide each side by 1.03 because I want to get V by itself. And so now V is going to be equal to 5.0192038835. And of course, that's way too many sig figs. So what I do is I go back up to my original problem. I'm going to ignore temperature because temperature is going to throw off our sig figs. Notice that everything has 3 sig figs except for the temperature conversion and R. So I'm going to have 3 sig figs in my answer. Now we're ready for the second example problem. So again, I'm just writing down my PV equals NRT, making my list PV NRT, so that I can make a list of everything that I have, starting out filling in R, which is 0.08206, just doing everything that I did in the last problem, nothing new. So they gave me the volume as 125 liters. They gave me the mass this time of oxygen to be 56.2 kilograms. They gave me a temperature of 21 degrees Celsius. And so the only thing I do not have is the pressure. So I'm going to actually have to solve for pressure in this case. So the first thing I'm going to do is take that 56.2 kilograms, and I'm actually going to have to find moles. But before I can even find moles, I'm going to have to get that to grams. So I'm going to do a kilogram to gram conversion, putting 1,000 grams on top and a kilogram on bottom. And then I'm going to do a second step where I'm going to get that from grams to moles, figuring out the molar mass of oxygen. So taking 2 oxygens, meaning 15.999 times 2, which is 31.998. and putting that on bottom and 1 mole on top. So using our stuff that we talked about in chapter 10 and 11 to go from grams to moles. And so I get 1,756.3597724 when I do my calculations. And of course I go back to the given, it's 3 sig figs, so I can only have 1,760 moles of O2. And so that's what I'm going to use for my moles. Again, the temperature's in degrees Celsius, so I'm going to have to change that to Kelvin. So that's going to be, when I add 273, 294 Kelvin. So now I have all of my units in the proper form. So now I'm ready to plug into my PV equals NRT. So pressure I do not know. I have my volume. My volume's going to be 125. My number of moles was that 1,760. My R never changes, 0.08206, and then my temperature is 294. So now again, I'm ready to do the math. I'm going to multiply all those numbers to the right together, and then I'll end up dividing it by 125. So half the battle is getting them into the proper units. You'll have to do pressure conversions, temperature conversions, getting them into moles. So there'll be some legwork to get it into the proper units. That's going to be most of the challenge. And then of course plugging it into your PV equals nRT. So notice that what we're doing here is we have 125p, and then we multiplied those numbers to the right, 4,200 or 42,461. And then we're going to divide those by 125, and then you get 339 with some decimal places. Again, go back up to the top. Notice that they're all 3 sig figs. You can ignore temperature. In this case, it's not as big a deal because it does have 3 sig figs as well, but you want to have 3 sig figs for your answer. So 340 with a decimal spot.